Good afternoon, everyone. A big thank you to those of you joining us in person, in the audience and virtually online. Thank you for joining us for today's program on integrating 5G technology for a more networked force. I'm Clementine Starling, Director of the Forward Defense Program at the Atlantic Council Scowcroft Center for Strategy and Security. Today, I am thrilled to announce that we are joined by Dr. Tom Rondo, Whitney McNamara, Dan Rice, and Colin Demarest for a discussion on how 5G and future G technologies can support US defense strategy. This event is the latest installment of our Forward Defense Forum, which is generously sponsored by Lockheed Martin. The forum is designed for defense leaders to put forth novel ideas for how the United States and its allies and partners can adapt, innovate, and win in future battle spaces. Our work here at Forward Defense focuses on generating ideas and connecting stakeholders in the defense ecosystem to promote an enduring advantage for the United States, its allies, and partners. It is essential for the United States and its allies to be able to rely on resilient communications capabilities, especially when operating in increasingly contested environments in Europe, the Indo-Pacific, and beyond. As such, leveraging next-generation communications technologies such as 5G is important to enabling greater speed, access, and connectivity on and across the battlefield. Integrating these technologies into the joint force enhances intelligence, surveillance, and reconnaissance, ISR, which enables the warfighter to make sense of an ever-changing security environment and the massive amounts of information that they face. The Department of Defense has identified 5G and future G as a critical component for enabling its combined joint all-domain command and control concept, JADC2. But to fully adopt new communications networks, the DoD will need to work very closely with allies, partners, and commercial entities. And the department is looking at how to do this quickly to keep pace with competitors' adoption of similar technology. For instance, we've all heard China's Huawei has emerged as a leader exporting 5G technology across the globe, including to US partners, placing those nations at potentially an increased risk of cyber attacks and espionage. Moreover, current US battlefield infrastructure and weapon systems may be incompatible with advanced communications technology or particularly vulnerable to adversarial attacks. So one of the key questions that we'll be asking today is how can the Department of Defense set a new course for advancing a safe, secure, and reliable 5G and future G communications architecture to support its mission sets. So in today's discussion, the fantastic panelists that you'll hear from will consider the future of military 5G and how the joint force can leverage next-generation communications to boost operations. So we are honored to be joined by Dr. Tom Rondo, the US Department of Defense's Principal Director for Future G, Whitney McNamara, a non-resident senior fellow here with us at Forward Defense at the Atlantic Council and a vice president at Beacon Global Strategies, Dan Rice, Lockheed Martin's vice president for 5G.mil programs, and Colin Demarest, who will be moderating this conversation, who's a defense reporter at C4ISRnet. As a reminder, this event is public and it's on the record. We really encourage audience questions. Both our in-person audience and our online audience can submit your questions at www.askac.org. So askac.org. Please submit your questions, and Colin will do his best to pose those to the panel throughout the discussion. So without further ado, thank you all for joining us, and Colin, over to you.
Hey y'all, I'm Colin Demarest, a reporter with C4ISRnet. I'm a little eager for this conversation, as you can tell. As it was introduced, I'm joined today at the Atlantic Council with Dan Rice with Lockheed Martin, Whitney McNamara with the Atlantic Council and Beacon Global Strategies, and Dr. Thomas Rondo with the Department of Defense. Let's get a baseline so we're all on the same page here, and I'll turn to you, Tom, and you, Dan, first. Maybe what is 5G at its most basic, and what are those advantages it offers as compared to its predecessors like 4G?
So if I can start, so I've been in the world of RF and mostly software-defined radios for a couple decades now. Tracking the cell phone technologies and where we got to with 5G, the revolution that 5G changes the game for the DoD. So up to 4G, it was all about trying to find a single kind of killer app, although we always miss the killer app, right? 2G was about voice, turns out it was about SMS. 3G trying to get data out there. 4G really perfected the data model. But the change that 5G has from the perspective of the Department of Defense is, if I can try this metaphor, right? So we're sitting in DC on the East Coast, so I-95. 4G is a brilliant way to move a ton of traffic across a network. And it's like if we had to build I-95 to every single endpoint, if I had to build I-95 to connect DC to Richmond, but also to go to the grocery store or a school or to the Pentagon. 5G allows us to tune how the network performs per application requirement. And every single application the DoD has, every service, every platform has a niche requirement from its network. The ability to tune that to take advantage of the different properties of a network to fill those different gaps is one of the really exciting things about it. I'd say the second thing is the security posture. So as these new niche markets are going to come up, or these new verticals are being defined, we're talking more and more, the connected vehicle, telehealth, all these now safety of life, critical functions that a network can provide us. So therefore, the commercial world is taking security far more seriously than it ever has in the past. We get to benefit from that. So we get to utilize the investments of commercial industry and put it to work for the DoD. Caveat though, DoD, our operations, we're under the advanced persistent threats. We have nation-state attacks against our networks all the time. So we do have to take it to a slightly enhanced look at the security posture and what it means for us. And we can talk more about the different projects that we're investing in to try to figure out how we can fill those gaps and understand what the real security posture looks like for us.
That'd be great. Dan, from the industry side of the aisle.
Yeah, just building on what Tom said about the tuning of the network for different applications. You can think about 5G delivering services at 3 different points in the triangle. There's an enhanced mobile broadband, which delivers that very high bandwidth data. From a defense perspective, that's very useful for things like ISR applications, where you've got a large amount of data you're trying to move. And as an example, we've shown that you can use 5G to move very high bandwidth requirements for information exchanges like raw RF IQ data, which is the basic information about an RF signal, and reconstruct that at edge compute. Another corner of that triangle has to do with ultra low latency and reliable communication. So if you think about defense applications like command and control, being able to depend on the latency in a real-time sense, how long is it going to take to get there? Can I be sure that it's going to hit a particular real-time deadline that's needed for that particular application? Very important. Then the third leg of that triangle for applications that require large volume of endpoints, the IoT sort of environment. When you think about that internet of battlefield things or military things, large number of devices out there that perhaps don't need to send as much information. Maybe it's more intermittent, it's a lower volume, but it's across a large number of devices. There's a corner of the triangle that 5G can handle with the tuning of the network to support those kinds of applications as well. So those things are just the way that 5G is architected. I think the other thing that is interesting about 5G and a bit of a transition is that the infrastructure becomes very virtualized. So you can use general purpose processors to run a lot of this in the cloud or in an edge compute environment. And that makes deployment easier, it makes scaling easier, allows the network to be built out in a way that is more consistent with what we like to look for in terms of open systems architectures, open architecture and standards-based implementations. So you're not locked into a proprietary infrastructure. You can build on that from an open standards perspective.
And faster reconstitution of the network in times of war where kinetic actions happen.
Absolutely.
How do we secure that supply chain to get us rapid redevelopment and redeployment of these systems?
Absolutely right.
And so I'll throw the follow-up to the whole panel. Maybe you want to chip in here. For the average person, what sets it apart? Does the average soldier or the average person walking through downtown DC to get to the Atlanta Council even register the difference in terms of speed or connectivity or that sort of thing? Maybe if you want to chip in first.
I would say from the military perspective, at least, I think, Tom really foot stomped this. Just sort of it's not an evolution, right? It's a revolution in how much more throughput and capacity. And I think there's some really exciting applications, of course, for ISR and for Seed 2, but even really intricate things like untethered virtual and augmented reality, things for live simulation and training, which is going to be increasingly important for information warfare, things like telemedicine. And of course, all those, Industry 4.0 applications like automated manufacturing, really enhanced logistics, things that obviously both have commercial and military applications, but especially the logistics piece, which we see the DoD really trying to wrap its arms around. So those are the applications that stand out to me as extremely promising and sometimes maybe a little bit overlooked in the 5G conversation.
I think data rate is one of those big things. So the speed that you can move information. 4G and LTE unlocked video streaming as one killer app, right? We can all watch videos on our mobile device. 5G, when it reaches its potential, will be able to support immersive environments, right? Where you're in a 3D virtual world with multiple other actors, also seeing the same thing and interacting in a way that requires a lot more information to be moved back and forth between that compute environment and the user device. So things like that, I think you're going to see unlocked with 5G.
I think Dan makes an important point here when it reaches its potential, right? So we're not really seeing the full-blown 5G infrastructure that's really required to make those changes. I think capacity data rates is one thing. It's the overall capacity of the network that's really going to matter from the end user case. And it's not just one, you can download high-def video over 4G pretty well, but how many can do it simultaneously? But the other thing about adding that extra layer of bandwidth or capacity is the warfighter invention. These are men and women who are down on the ground, who are seeing the problems that they face when they're in competition. I think often about the 82nd Airborne, who's sitting in Poland right now, watching everything in Ukraine and learning from what's going on there. When they get their hands on this type of technology, they invent new ways to use it that we never would. And having that excess capacity enables them to grow beyond just what we might say what a requirement might do for them. But the other aspect that I want to point out, and this is really important from the perspective of getting outside of Washington, getting down to where our soldiers, sailors, airmen, guardians, Marines all live and work, and trying to understand their challenges. I don't want to overlook morale, welfare, and recreation, MWR as we call it. Getting 5G to the edge in our bases, so that they can be walking around with their families and they're living their lives while trying to do their jobs as our service members, is really important to them. So that's one thing that will change their lives for the better, while it's also creating these new opportunities for those warfighting capabilities that take advantage of all those different niches there. So lots of things that are happening here that using this technology to revolutionize how we behave. From the user, the kind of civilian perspective, the real thing that's going to happen is, when is that real entrepreneurial invention going to come to take over, right? As I mentioned, we've always missed the killer app of every generation of cell phones. No one really predicted Lyft or Uber. No one really predicted that the scooter that's now a market, before 4G and the miniaturization of that data link and GPS into that device, before that it was a scooter nobody wanted to buy. Now it's an entire market. What's the invention that's going to come after 5G? Those are going to be the things that we're going to really start to adopt and look back on and say, well, it was obvious, it was inevitable, but we're not quite there yet because that potential hasn't fully been realized.
Yeah, hard to predict where it's going to go. Yeah.
So lots to get back to on that and kind of circle back, but I wanted to ask one more basic question before we move on. What are some of the risks of 5G that DoD's watching, industry's watching, maybe outside analysts are watching? The GAO, for example, has raised the cybersecurity concerns, privacy issues, and costly infrastructure. And are those worries any different than the concerns we might have had for 4G or 3G or whatever you want to say?
Yeah, again, I'll ping back to something that Dan said. He talked about the virtualization of these networks. So now you have a sense of a network core that's managing all this data, that's a set of virtualized containers that are being spun up to provide services and different functions. And yes, there's a cybersecurity threat to that. It's software. It's always going to have a cybersecurity threat. But if we look at it just from that perspective, if we're concerned about that in the sense that we won't use it, I think we need to take a look at our posture on the cloud then as well. These are technologies that the cloud is using that we're advancing to telecommunications. However, It's different when you're talking about running all of the information from the edge, from the user device that's collecting all sorts of personalized information, that's presenting a signature of yourself as an individual, both over the air and the RF perspective, but also on the network. So we have to make sure that we're looking at those as different than just the cloud infrastructure that I think we're benefiting from in order to kind of let down, secure that. So we are looking in my office, a key tenet here is privacy enhancing technologies and additional security technologies in order to start breaking down those challenges that this commercial technology will always have for us.
So, agree with what Tom said. I also think that, the ability to use those virtualized infrastructure and that application level tuning, and in the cloud, as well as we're seeing in 5G, concepts like zero trust security, where every application, every user, every quanta of data that a user may have access to can be controlled individually, and you need to authenticate, and that entire end-to-end pipe from the data source to the consumer is encrypted in multiple different ways. I think you're going to see the U.S. government needing to add to what that commercial infrastructure is able to do. But in terms of the evolution of how cybersecurity has happened in the commercial world, whether it's with cloud or other computing infrastructures, you're seeing that same thing happen in the telecommunications industry. So we can take advantage of that as a starting point to layer on those additional capabilities that we're going to need for the most sensitive defense applications.
Yeah, I would just add too, when we always talk about technologies, it's like low risk, high risk, but it's like to what end are we using it? And I think that's always a big part of it when we're thinking about expeditionary operations, for example. We don't always bake the best cybersecurity into every tactical drone because the intel is temporary, or it's only important temporarily. And so just thinking through whether it makes sense to have, bespoke military communications that are really helpful for highly classified, really strategically important information versus more tactical information that if it did get interdicted, what could we assess that the damage is quite low. And I agree with Dan. I feel more confident now that we're baking zero trust architectures into everything. And we can always get smarter, right? Maybe we just build in end-to-end encryption into military mobile applications, things like that, that you would find on your cell phone, your WhatsApp, whatever it may be. So I feel less sort of that it's a threat, more like we're very sober about what the threats are, and we're managing them actively.
Thank you. I'm going to stick with you. The Department of Defense has said 5G is foundational to broader modernization, connectivity in general. So what happens if the department falls behind, is behind, or just ultimately fails in that regard?
I think 5G is one of those really critical enablers where if the department is not able to really adopt it at scale, it's going to be really difficult for it to realize its ambitions towards this more disaggregated and distributed force structure that it's aiming towards that's heavily augmented by autonomous systems. We see that reflected in JADC2. We see that reflected in how Replicator has been explained. And in these force structures, decision-making sort of gets pushed down, right, to the tactical edge. And so we see that smaller formations are going to have to given assets that allow them to generate effects, whether that's ISR, electronic warfare, mission planning tools, autonomous systems, which of course will require some bandwidth and comms at the edge. And that's really in contrast to how we've done things historically, right, where information is sent up the chain, decisions are made at a very high level and then pushed back down. And this force structure evolution isn't just a preference of the department. I think it's become very clear that this is a very important way for us to gain an advantage against a near peer, especially a near peer like Beijing that has been watching us operate in peacetime for a long time. They understand our reliance on, sort of long-range communication infrastructure, and have said that's, one of the first things they would take out in the beginning of a conflict. And so really now pivoting to more tactical forces, being creative to generate effects on the fly, that's going to make us a lot more unpredictable, more flexible, and it makes it a lot harder for an adversary to counter what we're doing, especially because, again, Beijing has spent lots of money on thinking through how to counter very specific capabilities and ways they expect us to operate, which is particularly frightening because our concept of operations and force structures haven't meaningfully changed in a very long time. And so not only will we not likely have access to, send comms up the chain and back down again, we probably don't want to, given the speed of processing power and information. We want to, allow our forces at the tactical edge to act locally and rapidly. And two, now with the ability to leverage industry and commercial innovations as well, it's a really easy way for us to gain a strategic advantage as well without really increasing our costs. And so we see how adopting a technology like 5G really enables a much more adaptable force structure that has really strategic implications.
Anything to add from either of you two?
So when I look at these things, kind of pivots off what we were just talking about here. We opened today with the whole combined JADC2 concept, right? You'll hear in that the whole sense, make sense, and act. So and that's a decision loop. And so the thing that I talk a lot about is decision superiority. You want to move that loop faster than your adversary, be inside their decision loop, so you can constantly be poking them, be moving them where you want them to be, so that you're now in a better position to do that. Communications and making decisions at that tactical edge is a key part of that decision superiority concept there. And these are the technologies that are going to give us that clear advantage. And I talk a lot about maneuverability in the electromagnetic spectrum. Again, these are technologies that allow us to have that maneuverability that's going to cause that chaos for our adversaries to try to fight against. And we do have the best warfighters in the world, and so they are creative, as I mentioned before. They are well trained, they are disciplined, and they're going to make the best use of that when they're faced with conflict and with adversary. So all those things come together to see how this technology is supporting all of those these concepts of decision superiority of the future.
One of the things I think 5G can offer, and it comes back to the idea of distributed architectures, because that brings an element of resilience, right? When the connectivity is there and you have the ability to talk to higher echelons, you're clearly going to use that. But when a group gets disconnected or a team is disconnected from that command structure, they need to be able to operate effectively, in that disconnected operations. We sort of view 5G as just one aspect of a way to build resilience. And I think it would be a mistake to think that our future forces are only going to use a commercial technology like 5G. It's going to be one data link, one set of a solution that's part of a hybrid communication and networking architecture. And so 5G can offer a lot, and especially in those environments where you're not as worried about detection and geolocation, those kinds of things. And even with some modifications, I think, use closer to the tactical edge. But interoperability with the existing and emerging tactical data links that have been purpose-built for particular use cases by our military, they're going to continue to be there. And 5G will just be one other aspect that gets integrated so that data link diversity is another aspect of resilience, just like that distributed architecture.
So there's been lots of talk within the Army specifically of reducing one's electronic signature, kind of reducing one's footprint to avoid that targeting, as has been seen in Ukraine. Will 5G be a concern in that regard from your perspectives, and what should be considered?
So we do have to respect the technology. Most commercial technologies are designed to make the receivers that the end users are going to have as cheap as possible. So therefore, they broadcast really high amounts of energy in order to make sure that they're discoverable. You turn your phone on from airplane mode, and the first thing it does is scream, "Hello, somebody come find me," right? And of course, that's the last thing that you want to do in that time of conflict, when you're in that weapons engagement zone, when you're in that really contested environment. So to Dan's point, we're going to have to understand how different hybrid approaches to the technology we're building for very specific, the pointy edge of the spear kind of, environments, to when you're in different phases of conflict or even phase lines of conflict. Now, one of the benefits of the technology behind 5G, and as we're pushing into future G, is the use of more and more of the electromagnetic spectrum, right? 5G introduced the idea of using millimeter wave up in the tens of gigahertz. We're now talking about the frequency range 3 band, FR3, which is between 7 gigahertz and 24 gigahertz. Now you have this huge opportunity, again, back to that maneuver space and taking advantage of the physics of those different pieces of the electromagnetic spectrum to your advantage. And because of the software definability of these systems, now we can start doing things within the spec now we start programming it slightly outside the spec. There's plenty of really interesting options that this technology gives us to make that maneuverability, back to that word, happen. I will say, I can't get into the specifics of it here, but I will say that we are working closely with our industry base to define new technologies that will help us with, enhance our low probability of detection, interception, our anti-jam capabilities within, standards compliant 5G systems. So there's plenty of ways forward to advance that. Finally, I will say that the other thing that I'm interested in when it comes to signature management is technologies that allow us to know what our signature is in the field. That's a thing we talk about. Some of the warfighters that I've talked to, they're in the field. Oh, I'm being jammed, right? So some Marines up in the top of Norway. Oh, the Russians are jamming us, and we look and with our magic crystal ball, and we say, there's no jamming in there. Turns out they just had the wrong setting on their radio system. These things are unknown, right? They're just, you program it in, you pray that it works, and connections, magic happens. We're also investing in technologies that are going to allow us to have more observability, more feedback within the network to, again, help the warfighters make the right decisions for what's happening around them, and make sure that they're more survivable and frankly, more lethal.
That's what I was going to say too. It's funny. I don't have a technical solution. Of course, we have smart power solutions and we have decoys that we could use. But to me, the first step in reducing one's electronic signature is to be aware of what you're actually emitting, which people would be surprised that most commanders, most force structures do not know what they look like on an enemy sensor. I know Young Bang recently said they light up like a Christmas tree. And he's not wrong. I think I read once that the average Army brigade has about 2,500 things that emits in that force structure. However, I don't see the Army becoming, a stealth force overnight. So I think one of the things that we really need to address is just to sort of bring back the lost art of missions control, right? So how can we manipulate the spectral picture that our adversary is seeing of us? How do we make sure our comms and how we're communicating through what links is unpredictable, make our pattern of life, our maneuver unpredictable? And for 5G, I know we've talked about like hiding in plain sight, of course, in mid and low band 5G, you could use host nation networks as well. But I would also assume that in a protracted conflict, adversaries would start getting smart about how you are using civilian networks. And so like anything else, absolutely use it as a tool in your toolkit, sort of hiding in plain sight. But I think like anything, it really is going to come down to the training, being aware of what you look like even on a civilian network. And without that sort of awareness or spectrum hygiene, but cyber hygiene is also good, that it's going to be hard for us to say like this pathway is good, this pathway is bad. It really just requires more situational awareness from the military to make those decisions.
Last words?
I think they covered it really well.
Perfect. So we talked about the Army, so maybe we can pivot here. I'm curious how 5G adoption and application might differ between the services, or what that maturity ranking is. Needs aboard a ship with the Navy are obviously different from the soldiers in a trench somewhere.
This goes back to the opening remarks that I made about how tunable and the software definedness of the 5G systems are. That's going to help lead us to being able to duplicate solutions and then tune them to the actual needs of the different services. You do see a lot of duplication in the services now with this type of technology. What we're trying to do from the Office of the Secretary of Defense perspective is to provide that voice of understanding the scope of it, and then again figuring out how we can utilize or repurpose this technologies for those different application needs. One of the things we've been studying is how 5G base stations behave on the sea. And of course, commercial solutions aren't ready for the wave patterns and the rocking patterns and the humidity layers and things like that all affect the electromagnetic properties of those emissions. We have to study those, but the lessons we learn there can then be applied to our lessons that we'll need to learn for airborne capabilities, which are going to have different physics behind them. So that's the work that we're looking at, is how do we actually use that tunability, that software definedness, in order to help not have to completely replicate entire solutions just for a little bit of a tweak over here.
What's industry's read on this?
Yeah, so I think it all starts with what is that use case that you're trying to solve, and what advantage can 5G bring to help whatever service solve that use case. And one of the big advantages, and Tom mentioned this earlier, is the cost of the devices, right? So if you think about the Air Force, would you use 5G on a next generation fighter to talk to in a crewed-uncrewed teaming sense? Maybe that isn't the first use case for 5G that the Air Force might want to take on. But perhaps using 5G on the flight line to gather maintenance information from a jet that's just landed or is on approach, perhaps in that hybrid network sense. Maybe it comes from a data link that already exists on the aircraft. And then using 5G to devices that are low cost, rugged enough to be used in that environment on the flight line, so maintainers can have the information they need, including AI-enabled edge applications, to do a more efficient job of maintaining that aircraft, turning it around more quickly, improving operational availability. And then because 5G has this concept not just of public networks, but of private networks that are deployable, you could take that same 5G network, those same applications, those same devices that the maintainers are using, when you're in an agile combat employment scenario. You're at a forward operating base, a FARP. And so I think you have to try to match, especially in this early adoption phase, the application, what benefit you can get from using 5G versus some other communications technology, wireless communications technology, and get the most advantage from that you can. That'll build the ROI, the use case, and as Tom said, we don't know what will emerge from that. You put it in the hands of the warfighter, they'll come up with new ways to use it that we never thought of.
You have anything to add?
They got it.
Okay, cool. I'll stick with you real quick because you brought up the flight line. Lockheed did a demonstration, I forget the date, but a couple months ago, let's say, involving AT&T and some Black Hawk data transfer. Can you maybe give us some details or color about that testing and what
Sure.
worked because of 5G?
Yeah, absolutely. So, our flight line up in Sikorsky, using a pre-DD-250, so we hadn't sold the aircraft off yet, so Lockheed Martin still owned the data. We were able to show how information that would come from a health and usage monitoring system on the aircraft could be wirelessly transmitted from the flight line back to our in-house networks and shared throughout the Lockheed Martin folks who needed to use that without having to carry a data brick from the aircraft, take it to the network, at a hangar, let's say, nearby and load it. And it was a substantial time savings. That even required taking that information off of the aircraft manually. We didn't add a data link to the aircraft. So if you take the next step and say either through an existing data link that's already qualified on the aircraft or through 5G that perhaps operates when there's weight on wheels on the flight line, moving all that information wirelessly is going to save a lot of time and labor associated with trying to move that information. We have also done the same thing with OUSD R&E. So we had an application that we used at Joint Base Pearl Harbor Hickam, was one of OUSD R&E's Tranche 2 environments. And Lockheed Martin was responsible for the application. It was AI-based. It was used with both fixed-wing fighters and rotorcraft. And we ran that on a Verizon public network and a private network. They're the contractor for the infrastructure at Joint Base Pearl Harbor Hickam. And just another example of how these applications can be used both on a public infrastructure and a private infrastructure, depending on the sensitivity of the data and what's available.
You guys also did testing. Oh, I'm sorry.
No, please.
So you guys also did testing by linking drones with private and public networks as well at one point, correct?
Yes, we did, yes. And so we've run 5G base stations on drones where that becomes the infrastructure that can connect to ground devices, user devices on the ground. We've also used user equipment on small drone aircraft to connect to ground infrastructure. And we've been using that really to sort of stress test how much data, what's the latency, how does the edge compute work? Can we really run an AI/ML application in that edge infrastructure and move large amounts of information in real time in order to solve problems like precision geolocation, as an example. So there's a lot of different use cases that you can imagine depending on how you put that infrastructure to use.
Before I cut you off, what were you going to say?
I was thinking about one of the exciting things we've been working on is the logistics piece of things, and brought this up as how important logistics is to the our ability to fight wars and to keep peace. So one of the things we've been working on is not only the smart warehouses, but when you think about logistics, it's not just about the network that connects how you move items from one place to another, but it's knowing where your items are and what weapons we have available and how to get them to where they need to be. And so these flight line mechanics that Dan talked about are things that we've been working on with the Air Force Warfare Center out at Nellis Air Force Base. Attached to Pearl Harbor is the Naval Air Station Whidbey Island. And what we're doing up there is they bring in the aircraft and we do that automated sweep to look for defects, corrosion, other impairments of the F-18. make sure that they are moving and fueled, and make sure that the refueling line is there ready for them so that they're back out of the depot and back into the fight as soon as possible. Again, it's that tempo, and logistics is going to help us with that tempo. I'll say with the Air Warfare Center, the F-35, that is a beast of a sensor system. The amount of data that comes off of that thing is incredible. How do we make sense of that fast enough that by the time that F-35 is ready to go back into its next sortie, it's reprogrammed with the data that it needs to fight its mission? That's to Dan's point. How do we actually get that data, make sense of that data, and move it to the people who are going to run those algorithms, make sense of it? We've been working with a lot of different edge compute and that high bandwidth aspect of 5G that's going to help out with that. And again, make sure we're constantly in the fight, we're constantly poking an adversary, we're constantly ready for them no matter what they're throwing at us.
So we hit on these base experiments the DoD invested in 2020 and 2021, excuse me. I'll turn to this side of the table and maybe ask you first, Whitney. Do you think the Pentagon should continue investing in those base experiments as were previously rolled out? And then maybe we can turn to you and see what you guys have gotten out of it.
Yeah, absolutely. And I think, too, the important piece is that a lot of the times I think the Pentagon can be accused of, experimentation theater, where we go, we fly some things, and we learn some things, and it doesn't always necessarily lead to the adoption of showing that something that worked. It's not always tied to a line of funding. And so experimentation is absolutely key, especially because, as Dan said here, when we're thinking about things like JADC2 and networked forces, you'd be forgiven for thinking that we want all things networked all the time. But I know my panelists know that that's not the case, right? We want some things networked when it makes sense for it to network. And a lot of that is really hard to capture in doctrine, right, and rules. And I think the department is sort of struggling with JADC2 because it really likes to wrap its arm around a problem first and then say, okay, if this, then this. If we're in this problem, we're going to use this comms node. And if we do, but it's just not going to work that way. It's going to be extremely scrappy and ad hoc how we think about operating in a contested information environment, in an expeditionary scenario. And so the experimentation piece is so important because the technology doesn't matter if we haven't trained to conduct C2 in very different ways at a more tactical level. And so for that piece, I think the experimentation should really be informing our requirements and how we should be leveraging this technology, not the other way around. So experimentation, absolutely, as long as we're hopefully codifying some of these lessons learned in TTPs for other forces to use as well.
What has Lockheed gotten out of them?
So, experimentation, I think, is really important because you start with a hypothesis. I think this technology is going to enable this use case to operate more effectively for this reason in this way. And when you run those experiments, you learn things, as you said, Whitney, that you may decide that it didn't work exactly the way I expected. I need to pivot in this direction. In some cases, you may say, we think this has got a significant advantage and we need to move this forward. In other cases, you may say, this wasn't a great use case for this. This wasn't a great idea. Let's set that idea aside and focus on something else that we think has more promise. But if you don't do those experiments, you won't learn what works and what doesn't. I think the next step, and by the way, that experimentation started in 2020 and 2021, but it still continues. There are phase 2 and phase 3 activities happening on many of these. Some were pruned, others have continued based on what was learned. But I think what's next is getting to that point where the things that did show the advantage, showed the promise, have demonstrated a return on that investment that makes sense. We now need to move that into transition and getting it out into a service program of record that takes advantage of what was learned and delivers it at scale so the service can actually take advantage of what that experiment showed.
Well, let me start by saying I'm biased. Right? So there's plenty of reasons for me to say we should continue this. What I will brag about first is we talk about roughly $650 million over the last 3 years have gone into these base pilot programs, or the tranches as people know them by, and then you look at industries money into this sector. We estimate roughly $100 billion a year of R&D that commercial industry puts into telecommunications. So that's how they're advancing. That's how much money they're putting into it. 650 million, 100 billion. Few orders of magnitude difference there. So what good have we done? And we've done a lot of good. hearing from industry, seeing how they're changing their perspective, their policies, how they're working more closely with us. That's a thing one, is they're now working more closely with the Department of Defense on these technologies than they have in the past. We built great relationships because of that. But also, back to this whole idea of what's the killer app for 5G, and if we're talking about different vertical markets, how do you bet on one of those that may take off, that may become that killer app? Or if you just dumped in another $100 million for something that doesn't work? The benefits that we have is we get to offset that risk, and that's what we've been doing. Is we've been postulating these questions. Can we use 5G to make smart warehouses for the Navy, smart depots for the Marine Corps? Can we use this to change the flight line of the future? All those things have a dual use concept to them that is feeding back into industry, that we're helping them accelerate and taking the risk off of them. And so they're actually telling us that we have changed their trajectory and how they're accelerating into finding these markets. But similarly, we've changed how the DoD sees the ability to use this type of technology. The conversations have shifted since I've only been in the seat for a little over a year, but I've been tracking it since my days at DARPA over the past couple of years. The vision that we have, the capabilities that we're comfortable with within the DoD have changed because of the work that we've done. And it's a lot of these experimentation, it's a lot of the focus on the rigor behind the science that we're doing, a lot of the cybersecurity and just security writ large that we're pushing into the industry. That is changing how the DoD's ability to adopt this and benefit from it and serve the warfighter purposes and make them more survivable, more lethal, more ready. All those things have actually been changing over the past few years. Dan's point, transition, right? It's very easy to invest in a test bed. It's great because it's a physical thing you can see set up and operating and running, but then it's using that test bed continuously for new experiments. What's the longer term return on investment of these things? Transition is similar. It's what is that, okay, we proved it, great, now why haven't you transitioned it? It's because transition is a long path to scale these things up from one experiment, one or two or a few boxes that we've built, to an actual supply chain that the DoD can actually purchase, acquire, and utilize and have ready for them. That's an order of magnitude more effort in many cases to get us there. That can be hard to swallow sometimes. And so it's this push and pull that we have to try to make sure that we're providing that the data that says this is possible. Ground up, let's show that this is possible. Top down, work with the services to provide that pull, and then close that gap over the next few years. That's where we're at, and that is a really hard problem. Colonel Heat Lyons always talked about at DARPA that transition is a full contact sport. And that's what we're living every day here, is to try to make sure that the good stuff that we developed actually gets that scaling and the support that it needs to transition appropriately into the services.
I'll underscore too that I've heard so many times anecdotally, and this is why I think getting warfighter iteration is so important, is that someone really tirelessly went, gosh, this software-defined radio is so great. It gets us so much more spectrum efficiency. It does all these great things. Someone tirelessly gets it into the hands of the warfighter after about 2 to 5 years. And then someone puts it in their backpack for a training exercise, and someone was like, well, what did you do? Well, I don't know what it is. No one told me what it is. It's not in my training manual. No one told me I had to experiment with it, use it. I'm just checking off the box of what I was supposed to do today, and it didn't involve this new widget that someone has handed me. And so making sure there's that catcher's mitt at the end of the transition as well, that folks know how to use it, they're excited to use it. The upkeep isn't burdensome where they don't want to do it. I think all of those are really important aspects to keep in mind as well.
In that regard, do you think 5G, the related tech, is a hot enough topic for these soldiers or these sailors or whomever to kind of know what they're doing, realize the tech that is in their backpacks?
I think people believe what they can see, right? And I think if people see it and they can see the difference it's making, they get excited. I think if it's intuitive, I just think like anything else, you're more likely to use it if it's making a meaningful difference in your operation. So.
And I think they're used to using it in their civilian lives, right?
Yeah.
So you hand them a 5G handset, if you tell them, I've tactically enabled this, you can use this for communications in these circumstances. That same device will connect to your tactical radio. You can run your ATAC application here. They want to use that, right? They'd rather use that than a piece of gear that perhaps is 10 years old.
Yeah, no, let me take the negative, a little negative side on this one, right? So yeah, they're absolutely trained to use that, but very few people understand how it works. And again, they see 5G on their phone now, so therefore 5G is solved. Why don't we just use it? Kind of concept, right? Electromagnetic, my PhD is in in wireless technologies. So I know electromagnetics and these wireless waves that are moving around here. I'm a wizard to most people, right? By being able to manipulate those waves and control one of the four fundamental forces of the universe. Super exciting, but what does the end user care about that, except that it works? So one of the consequences of this is we often forget about the importance of this technology working until it doesn't work. So Guam was recently hit by Super Typhoon Mawar back in May, I think it was. And luckily I know the General Farrow, who is in charge of the recovery effort for that. And they woke up the day after that typhoon leveled that island, and their comms were gone. And they immediately recognized none of the rest of the recovery effort is going to work unless they can get their comms back up and running. So that was a smack in the face that everything else is dependent on this. And so he's learned they're all in on working with us and supporting this type of technology because they realize how impactful it is to the rest of the grid, the rest of food supply, water supplies, all of that needs come into play here. So yeah, they're used to it, and then they're not used to not having it available to them. It's become this has become a critical technology for people to have in their hands. I'm not sure I know how to get home, and I live in DC if I don't have my phone on me. So yeah, this is important, but it's also important to work the background in order to make sure that those technologies are there, deployable, resilient, and available for us to use.
So before we jump to the next question, I would remind our audience, we are taking online questions, so you can file them at askac.org, and hopefully we can get to them. I'm going to stick with you, Tom. The Department of Defense CIO took over the 5G portfolio. I don't know if takeover is the right word. Maybe we can figure that out here right now. But what does that look like? What preceded that? And if takeover isn't the right word, can you give me a new one?
Yeah, this was part of the plan. It was the planned transition of 5G from R&E, where we do research and engineering and develop new concepts, and then eventually it has to go to some place that's going to continue to carry it out. And so implementation and transition, that's what CIO is designed to do for this. This was part of the original plan set up in 2020. 3 years of R&D within R&E, and then transition on October 1st of FY24 to CIO. We followed that plan. Now, because of the realities of the way that business happens, I'm going to say it, contracting. There's some delays that have happened, and so we're working closely together with them to complete the research aspects of 5G that we've been running for the past 3 years, while they're taking over the mature technologies that are ready for that scaling, implementation, and transition to the services. So it's really a handoff of mature technologies to make sure that they get the support that they need from that perspective, while we get to continue to focus on finishing the research of 5G and starting and earnestly attacking the research problems of future G.
What is the Pentagon's vision beyond 5G? Obviously, future G is in your title. Will there always be a future G to pursue, or is there like an end state nirvana we eventually hit here?
Yeah, so there's certainly a future G for, as far as I can fathom. This is a moving sidewalk. I'm stealing a term from a friend of mine who talks about the silicon industry as a moving sidewalk. Well, the telecommunications industry is also a moving sidewalk. You're on it or you're not. And so it's been moving since the 70s to produce the technologies that are now being called 5G. Roughly every 10 years, they're coming out with another generation of technologies. What is 6G going to look like? And that's what a lot of the conversations we're having in future G. Now, quick aside on that, from a technology perspective, I anticipate 6G being a lot of the perfecting of many of the ideas of 5G. Proving them out, building the markets and the end user devices that are going to require the kind of connectivity, device density, latency issues that Dan talked about early on. While we're also pushing into new frequency bands, and as we're trying to define more of a heterogeneous networked environment for ubiquitous connectivity. Many, many technical challenges to be solved there. Now, there's been a thought in the air, do we really even need to brand it 6G? And of course, my joke is that of course we have to brand it 6G because in about 5 years, the marketers are going to need something to sell. But we do need that. We do, so there is something to mark a line in the sand that says this is a new generation, a new push forward. We're going to continue to push on these things. We're going to continue to evolve these things. The importance of information, I think we all recognize, at this table here. in the battlefield for decision making in civilian infrastructure is super important. Our ability to make sure that we're driving the technologies forward with appropriate values embedded in them is critical. And that, I'm going to say, I think that's maybe a controversial statement to think that technology has values, but I'll argue if you look at what happened with the Chinese industry pushing what they called new IP into the 3GPP, the specifications body behind 5G and all 6G and so on, there are authoritarian ideas buried in their protocols. And if you can see that, you can understand that this is a threat to our personal liberties. It's a threat to our democratic views in this country. Luckily, the 3GPP also saw that and basically kicked them out. Now, they've been splitting that up and trying to force it into the ITU, the International Telecommunications Union, or the Internet Engineering Task Force. So they're trying to wedge these things that have authoritarian values into their protocols, into their technology. We've got to be there to be providing that security, the privacy, the democratic values that we want to observe in the same technology. So this is a competition space, and that's why, yeah, we're here for the long run in order to maintain that leadership within the technology area.
Where do y'all see future G, 6G, 7G, whatever you wanted to call it, going?
Yeah, I'll just make a comment following on from Tom there. You know, I think, you know, he made a joke about it, but the marketing aspect of it for the commercial industry, you can't discount, right? So there will be that terminology associated with that 6G. Before we get there, there's something called 5G Advanced. That's sort of the midlife upgrade for 5G, sort of like LTE was for 4G. So we'll see that. But I think in terms of the way the capabilities are now being deployed in this virtualized infrastructure, very software-based, it may not be as stark a cutover, like we got to roll out all the new 6G equipment. You know, it could be, well, we're doing our regular upgrades for our virtualized network infrastructure, right? Every 3-4 years, we're doing an update. You're getting the next generation of general purpose processors out there in the cloud. And as you're deploying new capabilities via software update, it may not be as you know, sharp, bright a line that, hey, now we're switching to 6G, because that can be done in a much more seamless and, you know, consistent way across that software-defined network. But I do think there still will be that terminology because we have to have something
You need to
sell the next phone or the hat, right? Exactly.
Whitney?
I've seen enough innovation in the commercial sector every 3 months that obfuscates some challenge we had 3 months prior, or some approach that we were doing based on the assumptions we made about the tech that was going to be out there, to know not to predict that much far in the future, especially when it comes to U.S. commercial innovation. I think anyone that knows what's going to happen beyond 2 years should buy a lottery ticket. So,
So I'm going to stick with you. Tom, you hit on China and the competition that is in this space. Where would you assess China versus U.S. in the 5G race? I guess you can talk about development versus adoption versus international customers, or even global influence.
to me, there's 2 aspects that I think would really position us more favorably with China. I think one is just making sure that we are incentivizing all of industry to have this open RAN approach, right? Having that basically just approach that allows vendors to be interoperable, and that allows us to innovate on sort of the 5G tech stack. I think that allows us to harness all the great commercial innovation that we see in industry. And 2, it's an advantage against Huawei that's very much vertically integrated. So when they want to innovate, they have to replace the whole system. Currently, we have some bottlenecks, I would argue, in O-RAN adoption in the US, especially among smaller firms that have a tremendous amount of R&D spent on things like specialized chips and other aspects that would really have leap-ahead capabilities like passive deconfliction, 12 times the throughput of the spectrum, which we all know is, which is a finite and very congested space that would be enormously beneficial. But a lot of them do not have access to the capital like larger companies would to sort of develop these, or they haven't sort of heard the demand signal they need to use their own R&D funds. And so I think making sure that the O-RAN infrastructure and test and evaluation facilities to make sure that they can get certified, that they are interoperable with O-RAN, that they are secure is really, really critical. It's not to say that incumbents don't have tremendous amount of technology, but I think especially as we're looking at the broader competition, supply chain resiliency, we want to be incentivizing some of those smaller firms pursuing O-RAN to make sure they have access to capital, and that we could just make competition better. And then the second one would be already to start thinking about how to leverage 5G into low orbit satellites. I think that will be the next iteration that will be really important for us for discrete use cases, of course, to start enabling. Those two things combined, I think, could make sure that we, maintain that lead against Beijing.
Yeah, agree. And I think the advantage of those Open RAN standards, those O-RAN standards, are that smaller businesses can compete on just a portion of that stack. You don't have to try to have all the capital and the investment necessary to deliver an end-to-end solution. You can choose what part of that ecosystem you want to compete in. And if with the interoperability and the ability to test that against standards, and NTIA is doing a lot of work in that space as well, you're able to then show how that could be delivered into any O-RAN infrastructure. But I do want to come back to the point you made about experimentation. So please. One of the side effects of the investment that the department has made in 5G experimentation is that it has enabled some of this O-RAN to advance more quickly than I think it would have left to its own devices. So, commercial industry, the major, carriers, the wireless network operators, they're very interested in this O-RAN-based solution as well. But their ability to push that with their supply chains is limited to some extent, right? They need to make sure they're getting the best performance, the highest value they can per dollar. And although they would like that ability to mix and match within that stack that they're using to deliver their commercial infrastructure, sometimes it's hard, right? Because you'll get suppliers who are willing to offer you a better deal, or you're going to get our best if you stay with the more proprietary infrastructure. Because OUSD and the department put such a focused effort on, we are going to go with O-RAN, this is going to be required, got it codified into the NDAA language, I think that has really helped the supply chain, including the US-based carriers, to recognize that this really is important and we can find ways to accelerate it. And I think it's given that US supply chain, the folks who are trying to break in, become major players against some of the foreign competition, a leg up in accelerating the maturity of those solutions. So,
did you want to hit on O-RAN?
So only in the sense that I think these two have sold O-RAN. I don't think I need to go into more of why it's necessary. All those points are valid. Just want to kind of come at it and say that we are, as Dan mentioned, and DoD, all in on O-RAN or Open RAN. He gave me some kudos, or our office for supporting that. Likewise, we're now, the Marine Corps this week is kind of finishing up one of their latest spirals of the OSIRIS platform that Lockheed Martin is the prime on out in Camp Pendleton. So we'll be getting a lot of good data on an actual Open RAN architecture that is designed for Marine Corps Expeditionary Advanced Space Operations uses. So I'm really looking forward to getting the feedback on that one. So that's part of the partnership that we've created to advance the Open RAN concept for us.
Turn back to you again. In the opening remarks, Huawei was mentioned, ZTEs in the headlines. Do you think the U.S. is successfully boxing out that allegedly sketchy or kind of tainted equipment or tech? And then, how do you protect yourself while also letting smaller companies or like someone that isn't as big as Lockheed into the party?
I think we won't always get this lucky, but I do think sometimes Beijing can be its own worst enemy. And so I think there was a time there where we all worried that they were sort of winning that global tech race, especially as European allies and other countries were adopting 5G. But I think what we've seen now is Beijing cannot hide who they are. They cannot hide their sort of nefarious plans. So I think in that sense, we're seeing sort of folks be a bit more cautious to that. And I expect that to also come out as Beijing tries to export more technology as a global tech leader. Again, we won't always be that lucky, so of course it's still very important to stay ahead, and I think, again, focusing on O-RAN adoption, things like low orbit satellites to sort of help with areas where we don't have fiber optic cables, things like that I think can really push our advantage. But I think that I will always say this, that I think our greatest strategic advantage is our industrial base. And so as long as we're setting the standards for things like zero trust, we have standards for ORAN, for how to make sure you're secure and interoperable and a team player in this tech stack, I think we're always going to find ourselves ahead in the long run. Not that we can rest on our laurels by any means, but I always bet on us.
You're going to say something?
Yeah, I wanted to pivot off that because what Wendy's pointing out here, to me, is the whole of government approach that's required as well. This isn't just a DoD thing. I work very closely, with the National Security Council, Department of State, Commerce, Energy, everybody who's kind of in on this. And as we look at some of the issues that we're not just, innovating and building tech is critical to maintaining that advantage. There's also really good policies that we can put in place to also position the U.S. in a better place. You can actually see the downward trend after some of the policies put in place that were counter to Huawei's global trend towards domination. It had an effect. Policy really had an effect on their business practice, and they've had to recover. Now they are, and these things are workable. But that whole of government approach is really critical. And part of that too is, again, not just building technologies, not just creating this tech that I talk about, these democratic values. Back to that whole thing. When I talk about autocratic values and inserted in technology, we look at that as a bug. Plenty of other countries look at that as a feature. So we also have to be on top of that and understand the landscape and understand how to work with them to help them to expose the challenges, provide solutions, not just slap their wrist, but also provide solutions to those challenges that they face. So this is more than just the DoD. I'm just pleased that we're here providing that the initial kind of investment into some of the core tech that's being produced for future G right now.
And I'll float this out to the whole table here. How would y'all assess industry's appetite for 5G, the way it's matching Pentagon requests? Is it one for one? Is one ahead of the other? I don't know if you want to go first or who wants to take that.
I think there's more supply than there is demand, which says a lot because the department has a really, really healthy demand. But I think that's sort of the benefit of having such a strong industrial base, that the department has a lot of sway and swaying billions of dollars being sent in commercial technologies that have military applications. It's not a bad problem to have, to be sort of tech horizon scanning and thinking what's the most cost-effective and compelling technologies that we can leverage for our advantage. So I don't think that's a bad thing at all. And I think actually what we've seen in the past couple years is just tremendously improved government-private sector coordination to make sure that that relationship is more symbiotic. So,
yeah, I would agree with that. I think that you're going to see the commercial and industrial applications. They're going to drive the mainstream of 5G more than government can. But I do think the requirements that are coming out of some of the DoD use cases, as an example, are driving certain aspects of the standards that wouldn't naturally get adopted first in a commercial implementation because of the way that they want to get used in a DoD application. So as an example, capabilities like integrated access and backhaul, being able to use the same wireless link that you talk to a user device to backhaul wirelessly from a base station to the next base station to the next base station, doing range extension and taking better advantage of that spectrum. There's clear DoD use cases for that in a austere environment where you don't have, power and fiber drops, as an example. So are we seeing use of that in the commercial world? Yes, but it's a little bit slower. The requirement that's driving that is a little bit slower than what the DoD is. Same thing with SideLink, right? SideLink is a use for V2X, vehicle-to-vehicle communications, enables two user devices to talk to each other without going back through a base station. And so you can imagine for a commercial service provider, you really don't make a lot of money off of two user devices talking to each other. You make money when it comes back to your base station and you can charge for the minutes or the data or whatever that you're communicating to. But really important both for that V2X, the vehicle to vehicle, but also in a lot of DoD use cases where you're trying to create mesh networks of end user devices. And I think that those requirements that we're seeing coming out of these experimentation and other activities are helping to drive the industry forward, especially that U.S. ecosystem.
Yeah, I'd say who's ahead. It depends on which lens you're looking at it through. What I would say, is you want to build a fighter jet. You come to the DoD. We're going to work with our defense industry base, and we're going to build the best fighter jet in the world. Soon as commercial industry figures out how to make money off of something, they're going to do it faster and better than we ever will. So we're taking advantage of their running towards things that have market solutions and customers on the other side. Dan pointed out a good couple of 5G capabilities that are lacking in that customer demand, but not the DoD demand. I'll point out, I'll bring some more jargon into the discussion, something we just showed off in a NATO exercise last year, 2 weeks ago now in Latvia, where there's a thing called the non-3GPP interworking function. What this allows you to do is connect a non-5G modem to a 5G network. Now, why would you want that? Well, Wi-Fi 7 is what industry thought they would want from there. What we want from there is there are specific tactical radio links that we've designed to be survivable under certain conditions. Wouldn't it be great to control those through a 5G network without having that signature overhead of a 5G modem? We also have SEP. And I always forget what SEP actually stands for, but it's the new secure protocol for roaming. And it's a different approach to securing that, and it's a different way of addressing the authentication and the security posture in a roaming environment. That's with a standalone core. So you have to have 5G standalone to have this SEP protocol out there. Well, we went to the range out in Latvia, and we worked with Ericsson and Nokia. Sorry for bad-mouthing them, but I've said this to their face. They didn't have either of those interfaces. They didn't have SEP, and they didn't have N3 IWF. Well, they don't have the customers demanding that from them. So we had to bring it ourselves. We brought an open core. We had them, those functions were built there, and we were able to execute a mission where we actually rehomed a U.S. military tactical device to authenticate back in Idaho, in this particular case, and then be able to operate within the 5G core that we had deployed out there. So that's leading industry in a lot of these efforts that they weren't investing in or inventing themselves. Now, word of that got up to the high chain and Ericsson, Nokia, and I bet next year when we do this exercise again in Latvia, we'll be able to utilize their core and their radio access nodes that are out there. It's gonna be great. So we're really trying to understand what aligning incentives is often talked about between industry and government. Sometimes I think alignment is maybe too grandiose or too never going to happen. Understanding incentives and working to build ways that we can actually make use of their incentives and they can make use of our incentives. That's what we're trying to do with our industry partnerships. And the Latvia case was a really good example of that.
Yeah.
I'm going to jump to audience questions, so this may feel a little like a lightning round. And for those who might have joined us late, you can send in questions at askac.org. This person, Byron, asks, Dan, what's Lockheed Martin's business advantage in this market? Is it partnerships? How do you characterize your company's position compared to other contenders?
So Lockheed Martin is trying to find places where we can add unique value to what the commercial industry can bring for a 5G solution. We are working with a wide variety of commercial industry players to help develop what we think is an interoperable tactical edge network that leverages 5G and the 5G architecture as part of that. Where I think Lockheed can add value as a major systems integrator and prime is, we have platforms and systems across all domains that operate with all services, so we're a microcosm of the defense industry. We also work with all of the other defense, aerospace and defense players. So when you think about a solution that by its very nature has to be multi-service, multi-domain, it has to be a multi-vendor environment, it has to be interoperable across those existing tactical networks that we're very familiar with, I think that's where Lockheed can bring value to what the commercial industry on its own is trying to deliver for the DoD. So our approach really has been to gain strength from developing strategic relationships with the best industry players out there who want to have the same vision that we do, want to deliver and support our warfighter the way that Lockheed Martin does. And we take advantage of that, we adapt it, we adopt it, and we enhance it for the needs that we see in those DoD use cases.
And if I could follow up with you, Whitney, maybe. Do you see these companies grouping together to handle 5G, or is it kind of just these single kind of parties?
No, I think that there has been like a signal that to maintain an advantage, industry should cast a wide net and use the advantages that they have inherently from decades being system integrators and their own internal innovation, but also be looking at the commercial market because it is so diverse and thinking what parts of that can be complementary to their existing approaches. I think especially in the past 2 or 3 years, you've seen lots of primes standing up venture capital arms and are looking more proactively for partnerships so they can bring the best capability to bear to the department.
Our next audience question comes from Tyrell. It's for you, Tom. You mentioned tuning 5G applications per requirements. What are some of the near-term use cases of highest interest for 5G or next G for integrated sensing and communications?
Yeah, ISAC, right, integrated sensing communications, that's a really interesting one. It's actually one of the themes, so the 4 themes that we've defined for future G. Integrated sensing and communications is one of those. So that's a part of it. The question could be taken very broadly, but there are niche applications. I think control of UAVs or just unmanned systems in general. I think some of the integrated sensing of not integrated sensing communications. I'll get to that in a second, but integrating multimodal sensors. So the way that I think about the challenges that we're going to face in an agile combat employment or in expeditionary advanced base operations. When you get down on the ground there, you're going to need to establish your communications and your perimeter security infrastructure very quickly, and it has to be movable and kind of almost a self-healing network. And so you want to have all those sensors integrated with you. That provides a burden on the spectrum, on the network capacity, and on those different network opportunities that are presented there. Now mix that sensing environment with a fires environment. So now you want to actually have fires control. Now you probably want to have a different network slice dedicated to that, not only from a mission capability perspective, but also the security posture that you need to take. If you're just taking information, trying to make a decision, it's that's one level of security risk. If you're actually controlling fires on a target, you've got to ramp up your risk profile a little bit there. Now, integrated sensing and communications is a really exciting new idea that's really being pushed in the kind of 5G advance into the 6G world. This is where you can actually use the communication signals themselves as sensors. So DoD builds very exquisite sensors. We call them radars. Now, the radar range equation will tell you a lot about what the center frequency and the bandwidth of the signal will do for your ability to sense something that's out there. We make very, very physics-based decisions on those parameters in order to complete the mission. Is it an early warning system? Is it a 3-dimensional tracking system? Is it a fire control system? What's happening as we expand out to the low band up to 6 gigahertz, this millimeter wave, up in the tens of gigahertz, and this FR3 band and the mid gigahertz there, that plus the new bandwidths that these signals are producing are creating really interesting opportunities to use those as in different radar modalities while you're also passing communications. Now, we're going to study that, how we can use that. Obviously, our radar systems produce a lot more power than a commercial cell phone system typically does. But what's the system architecture look like? But also, what does it do against us? Now, as we're operating around the world, that starts to become a threat as other people are figuring out how to use this technology for the same purposes. So both those things are of keen interest to the future G work that we're going to be pursuing in the future.
So I think we have time for 1, maybe 2 more questions here. I'm going to take this audience member's question and kind of morph it. Where do you expect DoD spending on 5G future G to go in the future, out a couple fiscal years? I don't know if you want to take this first, maybe?
I think with the way it's going is obviously going to be very focused on microelectronics as a way to shore up our ability to adopt all of these technologies in the coming out years. I think it's going to require a really hard look at our domestic supply chains, allied supply chains, and figure out too, obviously microelectronics is an extremely diverse industry. We still need obviously basic chips for everyday items. We need specialized chips for a lot of these really forward-leaning applications we've mentioned here, like untethered virtual reality. But that, I don't envy the person's job, maybe that's you, Dr. Rajo, to figure out sort of
right
what is the breakdown between the CHIPS Act, between DoD Microelectronics Act. There is a lot of money being spent, but there's a lot of diversity and a lot of microelectronics that could provide a really meaningful advantage, not just for 5G, artificial intelligence, all that great stuff. So I would expect we would need to get that right in order to make sure that we're in a good position to adopt a lot of these technologies in the coming years.
I do sit as the advisor for 5G and 6G to the Microelectronics Commons, which is how the DoD is using its Chips for Science Act money. So yes, I'm on both sides of that conversation.
So we have time for one question. So I'm going to maybe do a quick answer here for all three of y'all. What is a 5G misconception we can dispel at this table? We have 39 seconds and counting. So Dan, you want to take it first?
I think one misconception is that it is a standalone technology that just operates in a vacuum, right?
I was going to say it's a panacea like anything else, right? We just need 5G, we just need AI, they're enablers. I think better understanding sort of the advantages and inherent risks and limitations in technologies and how we want to use them is really important nuance that sometimes is missing in the emerging tech conversation.
You get the last word.
I think the misconception is that China's won and they're dictating the security posture of our future information systems. We're not done yet. We're not near done. They have not won, and we're back in the fight, and we got a lot of good ideas for how to combat that.
Well, we will have to leave it at that because we are out of time. Thanks again to our guests today and to the Atlantic Council for hosting. Hope you all have a good one.